Hello friends, welcoming you all to my YouTube channel Aviator Updates. If you don't know me, I'm Rakesh Negi and I'm an aviation enthusiast. In today's session, I'm going to discuss about Magneto or Magneto Ignition System. Okay, so let us start. Magneto, or we can say Magneto Ignition System. Ignition System. So friends, in today's session we'll be discussing what is a magneto, what is its working principle and its working or operation using a schematic diagram. Okay, so let's start. So friends, what is a magneto? A magneto ignition is basically one of the categories of ignition system in reciprocating type engines. It is a self-contained unit and is driven by the engine and supplies power from its own generator. We'll discuss more about this soon. In reciprocating type engines of aircraft, magneto ignition is one of the most commonly used. And if I talk about the principle of magneto ignition system, it is electromagnetic induction. I mean to say the principle of magneto ignition system is electromagnetic induction. And if I talk about magneto ignition classification, they can be classified as high tension or low tension ignition system. And these high tension or low tension magneto ignition system consist of some principal components which are contained within the magneto itself, and we can say that basically it is a combination of a permanent magnet, AC generator and an auto transformer. Okay, amongst the high tension and low tension magneto ignition system, the high tension magneto ignition system are most widely used, and the requisite alternating fluxes and voltages in this magneto system can be produced either by rotating the transformer windings between the poles of a permanent magnet. In such a case, the magneto system would be classified as rotating armature. And the requisite alternating fluxes and voltages in the magneto system can also be produced by rotating the magnet between the poles of fixed transformer windings. And such a magneto system is classified as rotating magnet. Also, one more technique is there which I can say is the third technique to produce the requisite alternating fluxes and voltages, and that is by rotating soft iron inductor bars between fixed permanent magnet and transformer windings. Such a magneto system is classified as polar inductor type. So as of now we have discussed what is a magneto and what is its working principle. Now let us discuss how does a magneto work by using a schematic diagram. So suppose this is a core. Okay, so this is a core which is made of iron. Okay, it can be soft iron or it can be any other type of iron which the manufacturer can use. Okay, suppose this is the core. Okay, now on this core a winding is wound, that is called as the primary winding. Suppose this is the primary winding. Suppose this marker represents this core. Then as I have said, the primary winding is wound on the core. Then what the manufacturer does is they used to wound the primary windings on this core. Okay, and for understanding, let's assume that the number of turns of this primary winding are around 200. Okay, and the primary windings are thick in nature. So what happens is one end of this primary winding is grounded and the other end of this primary winding, okay, which I am extending, is connected to a contact breaker. Okay, suppose these are the two contact points of the contact breaker and this contact is connected to the ground. Okay, and this is the contact, okay, which is conductive, of course. So this contact is attached mechanically to a cam. Okay, a cam which is coupled to a magnet. So suppose this is the cam, okay, CAM, cam, and these two are the contacts which make up the contact breaker. So I'm writing here as contact breaker. Next, this cam by means of some rotating assembly is connected to a permanent magnet. Okay, so I'm attaching this cam to a permanent magnet. Suppose this is the permanent magnet which I am drawing here. Okay, so this is the permanent magnet. I'll just finish drawing this permanent magnet. Okay, so this is the permanent magnet which is having north and south poles. So suppose this is north, this is south, so this will be north, this will be south. Okay, and this is the center of the permanent magnet. So this center is basically coupled to a drive shaft. Okay, drive shaft which I am not drawing here. We know that, friends, in an engine there is an auxiliary gearbox. From the auxiliary gearbox, a shaft is there, and this shaft, by means of some coupling, is coupled to this permanent magnet. That means this magnet can rotate. Okay, so I am drawing a direction like this to show you that this magnet can rotate, and this is the axis in which it will rotate. Okay, suppose this is the axis, so this can be rotated. So hence from here we can note that the permanent magnet can be rotated by the engine, of course, to the auxiliary gearbox and the couplings. And also about the cam, we can draw the conclusion that it is attached to the permanent magnet by means of some coupling or rotating assembly, right? Next, this end of the primary winding, this end which is coming, is also connected to a capacitor. Okay, we'll learn what is the purpose of capacitor after some time, but as of now just note that there is a capacitor here which is connected like this. Okay, and this end of the circuit is connected to a switch. That means this circuit is connected in parallel to a switch which is called as the Magneto switch. It will have two contacts. One will have off point and the other point will be for on. Okay, for turning on the magneto. So if you want to turn on the magneto, switch should be here, and if you want to turn it off, it should be here. Okay, that means it will have a grounding connection like this. Okay, off will have the grounding connection, and suppose we want to turn on the magneto, so I'll put the contact here. So this is the contact. Okay, so this contact is used to turn on the magneto. So I'll write here magneto switch. Magneto switch. Okay, so here we have the magneto switch having off and on positions. So now, as this is the primary winding, I'll just label it here. This is the primary winding. Next, we also have a secondary winding which is connected here. Suppose this is the secondary winding. So this secondary winding is thin winding and it is having so many turns. Let's suppose, as per the example which I am explaining, let's suppose that these secondary windings are having around 20 to 25,000 turns. Okay, and that is of thin wire. So I am extending it here. So whatever voltage will be induced, it will be given to a unit which is called as the distributor. So I am drawing the distributor over here. Suppose this is the distributor. Okay, so I am writing here, this is the distributor. So this distributor, it distributes the high voltage to the spark plug. How does it distribute? In the distributor, we will be having segments. So one segment is here. Suppose another segment is here. There's another segment and there's another segment. Okay, and this secondary winding is connected to a conductive point where we have a rotor like this. Okay, this rotor is made of an insulating and a conductive material. Suppose this is the insulating material and this end is the conductive point. Okay, so this conductive point end of the rotor is touching this segment. Segment is also conductive. Okay, so this distributor consists of a block. So this is a block and this is a rotor. Okay, this is called as the rotor. Okay, so note that, friends, distributor consists of a block and a rotor. So this is the block in whose periphery these segments, which are conductive segments, are circumferentially mounted. Okay, so how many segments I have drawn? 1, 2, 3, 4. That means 4 cylinders will be there, and the segments are sequenced, and the sequence depends on the firing order of the cylinder. Okay, like whatever cylinders are there in the reciprocating engines, in the order of firing as they are required, these segments will be arranged, okay, inside the block. So these are the conductive segments. So this segment is connected to a spark plug. Okay, I'm drawing it here. So this is one of the spark plugs. Suppose this one. This is the spark plug center section which is grounded. We know that well, right? Next, this other segment, when it is having the supply, will convey the high voltage to another spark plug. So suppose this is the another spark plug. I'm drawing just 4 spark plugs. Okay, so this is the center section, okay, of the spark plug center section is grounded, right? Next, this is another conductive segment which is mounted in this block, and it is connected to another spark plug which is there for the other cylinder. Okay, so this is also grounded. So likewise, the fourth segment is connected to the fourth spark plug, which I am drawing in this diagram. Okay, so these are the spark plugs. So this also will be grounded. So friends, what did we learn here about the distributor? The distributor consists of a block. Okay, so I should say this is a block and a rotor. Okay, hence there is a block and a rotor. If I talk about the block is in the circular form, and it consists of segments, conductive segments, which are arranged circumferentially, and these segments, they are arranged in such a way that they are as per the firing order of the engine cylinders. Okay, so these segments are conductively connected to the spark plugs. Okay, so that whenever the segments are having the higher voltage, okay, they will convey that high voltage to the spark plug so that the spark occurs inside the cylinder for burning the air fuel mixture. Next, that how will the segments get the supply? These segments, they get the supply or high voltage from the magneto unit. Okay, so this is the magneto unit. So the supply, suppose this is coming from here, so the high voltage supply comes from here and is given here to this rotor. So rotor is having this insulating and conducting part. This conductive part, when it touches this segment, it will have the supply, and hence spark will be produced in the spark plug, okay, to burn the air fuel mixture. From this magneto, there is some drive mechanism, okay, which will be coupled with this rotor, and this will cause the rotor to rotate, hence the name rotor. So as the rotor is rotating, it will be touching these segments in a particular sequence, and subsequently the spark will be produced in each spark plug inside the cylinders, so that the fuel air mixture is burnt within the cylinder. So friends, that's all about the distributor. Now let's talk about the magneto operation. I mean to say, how does it produce the high voltage spike so that it gives it to the distributor for operation of the spark plugs. Okay, so our intention right now is to produce the high voltage spike or high output voltage from this magneto. So for producing that high voltage, let us understand the operation of this magneto ignition system. What happens is, initially when the engine runs, so as the engine runs, obviously it provides drive to its auxiliary gearbox. From the auxiliary gearbox, a drive shaft will be there, which by means of couplings is connected to this unit, which is called as the rotor. So this rotor is basically a permanent magnet, right? So as you can see here, I have shown you north, south, north, south. That means it's the permanent magnet. So when this rotor is rotating, it will produce a magnetic field, a changing magnetic field, and that will be linked in this core. Okay. So in this core, what will happen is, since the magnetic field is changing because of the rotation of this permanent magnet, the magnetic field will be moving in this direction, sometime in this direction and this direction, and because of this, an EMF will be induced in the primary winding. Okay, so what we noted from here is a changing magnetic flux. Okay, you can call this flux as the main flux. Okay, so a changing magnetic flux is produced in this because of the rotation of this permanent magnet, and hence in this primary winding, an EMF is induced because of electromagnetic induction. So that EMF, whatever is produced, will cause a current to flow in this primary winding. So when a current starts flowing in the primary winding, that current causes a magnetic field to be produced around it. The strength of the magnetic field which is produced by this primary winding now, it depends on the rate of change of main flux, or rate at which the main flux is cut. Remember that, friends, main flux is produced by the rotor, right? So now flux is produced, and that flux is very much powerful. Also note that, friends, the current which is there in this primary winding, okay, that current also passes through this capacitor, and the capacitor shorts itself and it is charged. Okay, now when ignition is required in the system, the arrangement is done such that this cam will open this contact, and the moment this contact opens, what happens is the current in this primary winding will be cut off or discontinued immediately, because of which the magnetic field which it was producing, that magnetic field will collapse about the secondary winding, and when this happens, a very high voltage will be induced in the secondary winding. Okay, but remember that, friends, when the magnetic field of this primary collapses due to the opening of this contact, that magnetic field, though it produces a very high voltage, that is not sufficient to produce the spark. So in that case, what the system does is, there is a capacitor. Here comes the main role of capacitor. So when this contact is open, the capacitor would have been fully charged by then. So in that case, charge will be going in this line and it will be given to this circuit. So now what happens is the primary current will be more suppressed, and as the primary current is suppressed, okay, that means its magnetic field will collapse at a higher speed. So when the magnetic field of the primary will collapse at a higher speed, high voltage or very high voltage spike now will be produced and will be given to the distributor. Now when it comes to the distributor, from this it is given to the rotor. The rotor, as it is rotating, okay, will be conducting the high voltage to these segments one by one, and hence the spark will be produced in these spark plugs. So friends, also note that this capacitor, it prevents the sparking at these points and hence prevents the deterioration of this contact points. So when the current was flowing in this primary winding, okay, with this contact close, at that point of time it was sorted, okay, and in the circuit the capacitor is charged. So when this capacitor is charged, it is ready for discharging. So when it is ready for discharging, how does it discharge? So for its discharging, the current flows in this direction, okay. So when the current in the primary was collapsing, at the same time the capacitor is ready to be discharged. So when the capacitor is getting discharged, its charge flows in this direction, the opposite direction, okay. That means the primary current direction is this side, but the charge flow from the capacitor is in this direction. That means the capacitor's charge is flowing in this direction, in the reverse direction to the primary current, okay. And because of this, the current is suppressed, and when this primary current is suppressed, remember what happens? The magnetic field collapses at a higher speed, that means more faster. So when the magnetic field of the primary collapses now more faster, very high voltage, okay, will be produced, and that high voltage is given to the distributor, okay. And after that we already know the story, what happens, okay. So friends, I'll quickly summarize how does the system work, okay. Sorry, I forgot to label the secondary winding. This is secondary winding. Secondary winding. So friends, I have written this is the secondary winding. Now friends, let's quickly summarize the working of this magneto system. What happens is, initially the engine will be rotating. So when engine is rotating, obviously the gearbox also will be driven. So from the gearbox there is a drive shaft, which by means of some coupling is coupled to this rotor, which is a permanent magnet. This permanent magnet, as you can see, is connected to this cam by means of some coupling or rotating assembly, and which in turn is connected to this contact, which is the contact breaker, which can open and close timely, okay. Next, this rotor produces a magnetic field or flux in this iron core, and when this flux is continuously changing in this iron core, we can see that the primary winding is cutting this changing flux. Because of this, an EMF will be induced or voltage will be induced in the primary winding. As you can see, primary winding, I have labeled it. Now what will happen is, this voltage will cause a current to flow in the primary winding, so it produces a magnetic field, right, or magnetic flux, and the strength of that flux depends on the rate at which the main flux is being cut by the primary winding. Now in this situation, when magnetic field is produced by the primary winding, in this situation when ignition is required, what happens is, this contact breaker, the name is contact breaker because it can open, this contact breaker will be opened by the cam. So when this contact breaker opens, the current which is flowing in this primary winding will be discontinued. So why it will be discontinued? It's because this contact has opened. So when this contact has opened, the current will be suppressed, and as this happens, there will be a collapsing of the primary magnetic flux about the secondary windings, okay. And because of this, a very high voltage will be induced. But remember that friends, this high voltage in the secondary is not sufficient to produce the spark. So this can be assisted, this high voltage can be increased further, and that is by the role of this capacitor. So at this point of time, when this contact has opened, what happens is, this capacitor discharges simultaneously, and when it is discharging, the charge of the capacitor is flowing in the reverse direction, in this direction to the primary current. So when this happens, the primary current will be suppressed by the charge. So this capacitor is very much powerful, very high voltage it is having. So suppose the charge is coming in this direction and primary current in this direction, so this current from the capacitor will be suppressing the primary winding. So when this primary winding is being suppressed, it is happening at a very faster rate because of the presence of the capacitor. Earlier, when capacitor role we had not discussed, we came to know that though the primary current is collapsing because of the opening of this contactor, but the voltage is not that much sufficient to produce a spark. That's why this capacitor role comes in the picture, and when this comes in the picture, what it is doing, it is collapsing. It is reducing or discontinuing or suppressing the primary current at a faster rate. So when this happens, the flux of the primary will also collapse at a faster rate, and it will be collapsing about the secondary winding. And when this collapsing of the primary flux happens about the secondary winding, it will produce a very high voltage or very high voltage spike, and that will be given to the distributor, okay, for producing the spark. And how does the distributor operate? As we have discussed, it has a block having the segments. The rotor will rotate, it will touch these segments one by one, and in the firing order of the engine, spark will be produced accordingly in the spark plugs, and that's how combustion takes place in the engine because of the presence of this magneto system. Note that, friends, in some magneto systems, this unit and the distributor unit are within the same casing, but they can be as separate units as well. So friends, I hope you have enjoyed learning the magneto ignition system. I'll come up again with a new topic in my next session. Till then, enjoy learning this topic, and thank you.